Hi everyone. I am so sorry I cannot be there today. Today is the Jewish high holiday, so I wasn't able to be here. I know it feels like I've been out a lot, but that really has not been my intention. But you know, the good news is we're doing one of my favorite things today, which is logs. Now, my suggestion is to have yourself a handy TI-84 calculator or your nice TI-30SX, my personal favorite. Because we're going to be doing logs today. Now, I'll be showing you how to do logs on this, but I won't spend a lot of time on it because sometimes it's a little hard to read because it's not backlit on these videos. And I'll be spending more time on this calculator, but that does not mean that you cannot use your TI-30, okay? So, first of all, logs. Logs are used to find unknown exponentials and exponents in an exponential model. Logs are the inverse. So on our last quiz that we had, that question number 1, it asked you to estimate. Well, a couple of people knew what a log was and they were able to give a more exact answer. But again, I was just looking for an estimate. And the reason for that is because you didn't have the power yet to solve. And that's what we're going to be working on today. Okay, first things first that we got to talk about. You have to memorize what's in this box up here at the top. So you have to memorize this relationship to this relationship. Okay, now you got to get that memorized, super important. Now the good thing is after a few days of this, you're going to have it down, certainly before we take any kind of a quiz or a test on it. But I do want to be really clear that you have to know that. So B stands for base, okay? Then your X up here is your exponent. It is the same X that's over here. The B is the same B that's here. So base and base, base for the exponent, base for the log. And then of course we have our Y value here. Now here's how I remember how to do it. I use kind of a little circular thing to help me out. But again, you may not find this helpful. If this does not helpful to you, don't do it. Okay, so when I'm trying to convert from an exponential to a log, I always start with wherever the B is, and then I go under the equal sign, and then I go around over to this side. Now you may say, well, why would I do that? Because when I come to fill this stuff in over here, it's going to be log base B of Y, and usually the equals on this side equals X. So it's all about order. That's all it is. So I use the B first, then I use the Y, then I use the X. So I would do B, Y, X. Okay, now what if I'm going back the other way? Again, I'm not a big fan of having that equal here, so I'm going to kind of cross it out. I would start with the base. Notice I'm always starting with the base, go under the equal sign, and back around. So the base of the exponent is the exponent equals Y. So it's just a way to think about it kind of circularly. Let's try it out down here. So again, I'm going to start right here with the 5. Then the next number I'm going to use is the 125. Then I'll use the 3. So I'll write log. Now this has to be a subscript, so please make it smaller. Base 5 of 125 equals 3. So I went from exponential form, notice no word log, to log form. Okay, so again, this little loop around is just about the order that I write the numbers in. Now, what if I'm in log form and I want to go to exponential? Again, I'm going to start with the base. I'm going to go around to the 4 and then to the 81. So this will be 3, and you have to write this as a superscript, a little smaller, a little higher, equals 81. Okay, that's how you rewrite it. Now, we're just going to go down to this table and we're going to rewrite them together. As soon as you get the hang of it, you can write them on your own, pause the video, and see if you're doing it correctly. Okay, so this is exponential form. I want to go to log form. So the order I'm going to do things in is 2, 32, and 5. So log base 2 of 32 is 5. Let me switch colors so it's a little easier to see. Okay, let's do another exponential. I'm going to start with my base, which is 3. I'm going to use the 1/9, and then I'm going to use the -2. So log base 3 of 1/9 equals -2. Yeah, that's all there is to it. Now let's go the other way. Again, I always start with the base. The base is the base of the log. So I'll do 10, 3, and 1,000 will be how I use my numbers. So 10 to the 3rd power equals 1,000. Let's try another one over here. I'll start with 16. I'll go to 1/2, then I'll go to 4. So 16 to the 1/2 power equals 4. Okay, so hopefully you're starting to get the hang of it a little bit. And again, if this little swooping circle idea does not work for you, you can always just memorize the order up here. It's BXY, and over here it's BYX. You just got to make sure that you swap those around. Again, I'm going to get rid of that equals X over there. I'm going to put it over here. Okay, so that's conversions. So you may say to me, well, why do I need to be able to convert? Because you have been working with exponentials your whole life. And if I give you log base 3 of 81 equals 4, you're like, what? But if I tell you 3 to the 4th power equals 81, you're like, of course it does. So the conversion is helpful for us to be able to put things into our calculator as well as make sense of them when we first start doing logs. So let's try a little calculator activity here. So I have 10 to the x power equals 85. Well, right now I'd have to guess on that. So we're going to convert it over to logs, and then we're going to use our calculator. So start with the 10, go to the 85, and finally to the x. So log base 10 of 85 equals x. Well, you may be saying, I still don't know that, but this is a great place to use our calculator. So I'm going to reach for my calculator, and you'll notice down here on your calculator you have an LOG button. If you're using the smaller calculator, you also have a log button. It's right there. It's the same log. Now your calculator is automatically built to do log base 10. It is not built necessarily to do other bases, okay? So some of the calculators can and some of them can't. So the problems I gave you were log base 10, so you could do them on your calculator. Now the log button that's on your calculator is automatically preset to log base 10. So I'm going to push the log button. Do you notice it doesn't show the 10 for the log base? That's because this is a preset of 10. And then you just put in 85 and you close your parentheses and there's your answer. Now this said to round to the nearest thousandths. So that's a TH on the end. So tenths, hundred, thousandths, that's 3 decimal places. So we're going to put our nice integer, well, our nice number first in the ones position. Then we'll put a 9, a 2, and a 9, and that's your answer. That's what it equals. Let's try it one more time just to make sure you got it. I'll try it with the other type of calculator this time. First thing I'm going to do is rewrite this as a log. So this is going to be log base 10 of 14.5 equals x. Okay, so again, this calculator, just like the other one, is preset with the log button to do log base 10. You don't have to put anything in, it just does it. Close your parentheses. And again, we're going to do 3 decimal places. So our answer is 1, 1. Oh, got to put that decimal. 6, 1. And that's what your answer is. That's what it's equal to. So what does that mean? That means that if I did 10 to the 1.61 power, I would get about 14.5. Is it going to be exactly 14.5? No. And the reason for that is, remember, we rounded. In order for it to actually be 14.5, we have to use all the decimal places. All right, so that's the front side. The front side's about converting and using your calculator. Now let's go to the back side of our problems. Now we're going to have to do a little bit of graphing on this one. So in order for us to do that, we have to identify our log base and then select 3 values and graph our points. Okay, all right. So we're looking at it. We're a little concerned, but we're not, super concerned. It's going to be okay. All right, now, why do things work this way? Because we're going to be using a property, and I want you to put that right over here in this box. So I'm going to put a little star next to it, or maybe highlight it or something like that. That log base b of b to the x power equals x. Now, what's going on here is this is a property of logs, and I'm going to show it to you in just 1 second, but I wanted to get you to write that down first. You may be saying to me, but why does that work? Okay, let's rewrite it in exponential form. So that would be b to the x equals b to the x. So b to the x power equals b to the x. So that's absolutely a true statement. And if you remember from the past, if your two bases match when you're solving an exponential, x equals x. So this is just a nice equality property that's going to help us out. Don't worry, I'll show you what it means in just a second. Okay, let's go to our first problem that's right here and kind of work through it. I think it'll make a lot more sense. First thing you want to do, identify your base. All right, so my base is 2. Now the three values I'm going to be putting in my table, I'm going to, of course, have 2. And I'm going to put that right up here first, 2. Then I'm going to have 1 over 2. And I'm going to have 1. Okay, now you may be saying to me, I still can't put these in the calculator. It's okay. It's all right, because we're going to use our special property. So the first value I'm going to do is log base 2 of 2. Okay, right now, what's the exponent on this 2? The one that's right here, the exponent you can't see, the one that you can always assume. You're right, it's a 1. Okay, so right now, if I solve this, this is going to simplify out to be equal to, look back at your property, just whatever the exponent is. So this is going to come out to be 1. Now what happens here is your logs are canceling out. Okay, now what if I didn't know what this was? So I could just say, I'll just call it x. If I rewrote it in exponential form, this would be 2 to the x power equals 2 to the first. So x must be equal to 1, which supports our property and our assumption that we had right here before I scratched it out. Don't worry, you'll get the hang of it. Let's try the next one. So next one I want to do is log base 2 of 1/2. And I'd like to know what that's equal to. Okay, so remember how you want to rewrite it. We want to rewrite this so these are the same number. So this becomes log base 2 of 2 to the negative 1 power. So using that property that I showed you right up here, this will be 2 to the x power equals 2 to the negative 1. So x equals negative 1. Okay, let's try one more. This one's our tricky one. So I've got log base 2 of 1, just 1. That's weird. Okay, now this one is the hard one. And the reason it's the hard one at first is you got to think about 2 to what power equals 1. So this will be log base 2 of 2 to the 0 power. Because remember, anything to the 0 power is 1. That equals x. So that'll be 2 to the x equals 2 to the 0. So x equals 0. Now let's go over to our table and let's fill it in. So for 2, we got a 1. For 1/2, remember we rewrote that and it came out to be negative 1. And for our last one, we got 0. Now these points are specifically selected so they'll have that pattern for you. All right, let's go graph our dots. Let me graph them in red so they'll stand out a little bit more for y'all in the video. Okay, so first thing I'm going to go is graph over 2 and up 1. Beautiful. Then I've got over 1/2 and down 1. Also lovely. And then I've got over 1 and 0. Okay, now remember, this is supposed to be the inverse of an exponential. Which exponential? 2 to the x power. So when you connect this graph up, and down here, we are not going to cross our asymptote. Now, if I were in class right now, I would say to you, does anyone remember what the asymptote is for every exponential problem we did? And someone invariably would raise their hand and say to me, it's y equals 0. Remember, this is the inverse of that. So my asymptote is going to be x equals 0. Now let's talk about our x-intercept. Remember when we did exponentials, we did a y-intercept. Now we do an x-intercept. Remember, they're inverses of each other, logs and exponentials. Okay, so I'm going to come over here to my x-intercept, and there's my x-intercept. It's right there. You can either write this as a single number of 1, or you can say I want to write it as a coordinate, 1, 0. Now let's talk domain and range. Now this graph starts at 0, and well, it doesn't actually start at 0, it starts just past it and goes toward infinity for the domain. So I'm going to say 0 to infinity. And as far as my range goes, I can have any y values, positive or negative. So I'm going to say negative infinity to positive infinity. Now, I know there's a couple of you who are sitting there right now saying to me, I don't see how this is the inverse of 2 to the x power. Okay, well, let's think about what 2 to the x power is. So 2 to the x power would have looked like this graph. So here's my 2 to the x power. Okay, remember we did it last week. And whenever you're doing an inverse, it's simply the reflection across the line y equals x. So here's the line y equals x. And as you can see, this graph is just a reflection. So if we were doing the exponential graph, we would have 1, 2, 0, 1, and negative 1.5. And all we did to do an inverse is swap the x and the y. So hopefully that makes a little bit of a sense. Let's slide on down and let's do our last example. Again, this is supposed to be an inverse. Start by finding out what your base is first. So my base in this case is 1/2. Okay, so let me grab my scratch sheet of paper. And let's talk about what's going to go in this table. So I'm, of course, going to want a 1/2. I'm going to want 1 over 1/2. That's 2. And I'm going to 1. Okay, always these numbers. So it's always your base, 1 over your base, and then 1. Let's evaluate this. So first one I've got is log of 1/2 to the 1/2 power equals x. Okay, so if you rewrite this, it's going to be 1/2 to the x power is 1/2. Which means x, of course, equals 1. By the way, after you've done a few of these, you'll start to see the pattern that if you do the base, 1 over base, and 1, you're always going to get the same y values. Okay, let's try the next one. So I've got log base 1/2 of 2 equals x. All right, so remember, these have to match. So you're going to have to, this is our we're ramping it up a little bit. It's not the super hard one, but it's a little harder. So that means that this is log of 1/2. So log base 1/2 of 1/2 to the negative 1 power equals x. So if I rewrite this as an exponential, it's going to be 1/2 to the x power equals 1/2 to the negative 1. So x equals negative 1. So I'm going to come over and put a negative 1. Notice how that's the same as last time. We have 1 that equals 1. Then we have 1 that's a flipped over fraction. So we had to use negative 1. Let's go to our tricky one. All right. Log of 1/2 to log base 1/2 of 1 equals what? Okay, so here's our hard one. We have to think real hard. We have to say to ourselves, all right, what to the 1/2 power is going to give us 1? 1/2 to the 0 power. So I got to rewrite it. That's your tough one right there. Okay, now rewrite it as exponential. So that'd be 1/2 to the x power equals 1/2 to the 0 power, which means x has to be equal to 0. Okay, so we now have our values in. Let's go do some graphing. By the way, these may be out of order. Remember, it's okay as long as you finally get the nice curving graph. Okay, first thing, go over a half and up 1. Over half, up 1. Oh, let me switch to red so it'll show up a little better. Okay, that point's already kind of there, so it's not going to show up great. All right, over 2 and down 1. Okay, all right, and then we've got over 1, up 0, okay. All right, so let's, oh, sorry about shaking that. Let's connect our dots. Ooh, a lot of wiggly, sorry about that. Okay, let's take a look at our graph. So, remember this is just a reflection of graphing 1/2 to the x power. So notice it's going to be flipped over. Look at your asymptote. Remember your asymptote is going to be x equals 0 for all log functions. Okay, so x equals 0. Find your x-intercept, that's right there. Or you can just write it as 1. Either one works. Now let's talk domain and range. So domain and range for log functions is going to consistently be the same every time. You won't have any values on this side of the graph, like not a single one, which means you can't have any negative x values. It starts just past 0. So we'll use 0 to infinity. And then our range, well, technically we can have any y values. So notice we've got graph up here as high as 10. We got graph heading off down toward the bottom. So negative infinity to positive infinity. So that's how you do your graphs, and that's kind of, well, that's it when you're doing your logs. So let's take a quick look at your homework. Okay. So going over here to your homework, you'll notice that there are 4 graphing problems. I've left space for 3 points. Please use the pattern we talked about in the notes where you're doing the base of the log, 1 over the base of the log, and 1. Notice down here at the bottom, it asks you identify the domain, range, and asymptote for the problems. Number 7 asks you to describe the transformation that happened in number 4. Ooh, transformations. So you might have to like think about, what does a negative do? What does multiplying by 3 do? Down here on problem number 8, it's going to ask you to create your own log. Give it your best shot. Remember, you're trying to write an equation with a log base. Think about what would the 1/5 do? Think about reflecting over the x-axis. Think about, and it says use a base of 6. Okay, over here, these are really straightforward. They're just asking you to convert from log form to exponential form. That is all you have to do. Yes, some of them look crazy. That one in particular looks absolutely bananas, but it is not asking you to put them in your calculator. Do not evaluate. Just write. That's all you're doing here. You're just writing. So these should be really quick. Again, no evaluate. Do not touch a calculator to do that. You actually should be able to do every problem on here without the assistance of your calculator at all. Yes, I know I gave you a couple of problems with calculations with your calculator, but you just don't need them. All right, that's kind of it. I'll be back tomorrow. If you happen to be in 6th period, that's the group of people who didn't get to finish their quiz. Please look at Teams and your email so that you will be able to figure out which option you want to do to make up your quiz. All of those options are 30 minutes in length because that's how long that drill was. I just want to assure those of you who are a little worried about it, because I know we have had some long tests and quizzes this semester where you really had to push yourself. In all of the other classes, everyone was able to finish without any difficulty in the time they had, okay? I mean, everybody got answers. Everybody had stuff on their papers. They looked fantastic. All right, so I am looking forward to seeing you all tomorrow. If you are out for Yom Kippur, I'm with you there. We're fasting together, and I will see you tomorrow.